Okay, this is college algebra. Today we're going to begin our discussion on quadratic functions or quadratic models before we get into some power models, some more intense power models. Quadratic models are power models also, but only if they are, x squared sort of models. But we are going to take a look at some real world data here. So we've got mobile internet advertising is indicated by the table below. So here we've got some dollar values and projected dollar values in the United States of mobile internet advertising market from the years 2006 to 2012. We're going to create a scatter plot with x equal to the number of years after 2000. So we're going to let x, or our L1, be 6, 7, 8, 9, 10, 11, 12. And then our L2, or our y values, are going to be the advertising amounts in billions. So we're going to hit just stat. Edit, and I have already entered L1 and L2, so if you need to pause the video for a moment to enter those values into your calculator, do that. And we're going to find the quadratic function that best fits this data. All right, so stat calc quadreg, so that's number 5. We're going to draw from L1 and L2, and we're going to store this regression line into Y1. So vars, Y vars, function Y1, and then we're going to hit enter. So here is our equation. Now, if you have a TI-83, you're going to do the same thing, except it's not going to show up exactly the same. It's going to look more like this, where you have to enter L1 manually. So you do that by hitting second L1, that's the 1 button, then comma, second L2 button, then comma, then vars, y vars. So we'll do that part, vars, y vars, function. Okay, y1. And then you hit enter. You will get the same thing, all right? So here we've got our equation. Y is equal to ax squared, where our a is 0.0149x squared minus 0.105x plus 0.1372. I want to draw your attention to the r squared factor, and that's going to determine if this is a reasonable fit. So our r squared is 0.997. That's very close to 1. The closer to 1, the better the fit. Okay, so if you don't have this r squared factor, then you need to turn your diagnostics on. The way we do that, okay, is we hit second 0, and that's our catalog. And we're going to scroll down until we get, it's all in alphabetical order. We're going to scroll down until we get to diagnostics on. Okay, so again, if you don't see that R factor or that correlation coefficient, you need to turn your diagnostics on, hit enter, and then hit second enter to recall your quad regression function keystrokes, and then hit enter, and then you should see the R factors. All right, so we're going to use this model to find the year, so that's our X, that's what we don't know, in which the mobile internet advertising reached $3 billion. So this is going to be our question mark, and we want our y to be 3 billion. Okay, so since this is the y value that we know and the x value that we don't know, we're going to go to our y, and there I'm going to turn my plot on. So I hit enter on plot 1. I should see my quadratic equation entered into y1 because that's what I told it to do. And then in y2, I'm going to put 3. Okay, now I'm going to hit zoom 9. There's my data sets, my quadratic regression line, but I don't see my y is equal to 3. So I need to adjust my y max. Let's make it be 3.5 so that I can see my y is equal to 3. Okay, I'm not going to see the connection, so I'm going to need to go clear out. Let's let our x max, let's make it be 30. Let's see what happens there. That might have been too far. But we still will be able to see our intersection. So I hit second calc intersect, enter, 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 and I see that in the year 2017, I'm going to hit 3 billion. Now, the question arose in class, why is it that it's not 2018? Why don't I round up? Well, this is the number of years past 2000, okay? So in the year 2017, okay, I am going to hit 3 billion. I don't have to wait till 2018. So if you think about it in terms of years, then you can say that your final answer is 2017. The cloud. All right, so the North American cloud computing revenues from 2008 and projected into 2020 are shown below. So we are going to let the years be from 2000, okay? So we're going to allow, okay, we're going to enter our data, which I have already done, in L1 and L2, okay, where L1 is the number of years past 2000, so we'll start with 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then our L2 is our revenue in euros, or billions of euros. So we're going to create this scatter plot. Okay, and let's just take a look at it. So we're going to hit zoom 9, okay, and I still have my old graph on there, so I'm going to go back to y equals and delete that. So here's my scatter plot, and I can see that is just nearly a perfect quadratic equation, right? It's like a half a parabola going on there. So let's come up with the quadratic regression. So stat calc quad reg. I'm going to store it into y1. And here's my equation. So y is equal to negative 2.245x squared plus 11.10 crumbs. This is x. Y is equal to 0.2313x squared minus 2.245x plus 11.131. Okay, so here's my equation. Now, I can see that my r squared is really close to 1. It's 0.99956. That's a pretty good model for this data. I wonder how close it would be if I used a power model. So let's check this out. Second or stat calc, and I'm going to scroll down to power reg. And I'm going to store this, instead of storing it into Y1, I'm going to store it into Y2 so that I can see both at the same time. Sorry about that, Y2. All right, so there's my power regression equation. So my A is 0.069 times x to the power of 2.24. All right, so let's hit zoom 9, check out this graph. So the pink is my data, the blue is my quadratic regression, and the red is my power regression. That's mighty close. Let's see, what was the correlation coefficient? Okay, the correlation coefficient was 0.9991. So 0.99956 is closer to 1, so the quadratic equation is the better fit.